Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Mazki Bisakudin. Okay, today I will explain about part 5.1. Okay, for the question 1 is observe and sketch the waveform of the line voltage of two three-phase synchronous generator for time 0.5 to 1 second. So it show the RMS value, which is here, and simulate. So that we get the RMS value for G1 and G2, which is here. So it needs to be 0.5 to 1 second. Okay, so the RMS value for G1, which is 4.298, and G2 is 4.25. Okay, for question 2, based on the line waveform for two three-phase synchronous generator in figure 5.4, design parallel. Okay, after we do the series, and we should do the parallel. So the parallel is which is here, transformation to get the RMS value for parallel for G1 and G2, 0.5 to 1 second, and we get the same value, which is for G1 and G2 is 4.289. Okay, for question 3, show the analyze the line voltage waveform before and after paralleling them. Okay, for before paralleling them, so VLG1 is 4.27 and G2 is 4.26. Okay, after the parallel, we parallel the both synchronous generator, we get a 4.3 for G1 and G2. Okay, since the new frequency derived from the graph, we must the new time before creating the frequency. The time taken for start from 0.7 until 1 cycle for whole waveform as shown in figure. So T is 0.019. So 1 over 0.019. So we get the 52.932 Hz. Okay, that's all for me. Assalamualaikum.
Assalamualaikum and hi, I am Nurini Atira binti Gazata. I want to show you the waveform of the line voltage at three-phase synchronous generators for the time of 1 to 2 seconds. This is the circuit. This is a line voltage waveform and the RMS value. We can see that the waveform are not in parallel and the RMS value not the same with each other. After that, for the question 2, we need to design a parallel connection, and this is the parallel connection. From the parallel connection, we can get the waveform of load current after parallel at generator 2. This is the waveform for the time of 1 to 2 seconds and the RMS value. After that, we find a load current waveform before parallel at generator 1. So this is the waveform we need to set up for time 1 to 2 seconds. And this is the RMS value for load current waveform before parallel at generator 1. After that, we need to find line current waveform of synchronous generator 1 and 2 before parallel. This is the waveform for the time 1 to 2 seconds and the RMS value. We can see that they have a different of generator 1 and generator 2. After that, this is the parallel circuit. We need to find line current waveform of synchronous generator 1 and 2 after parallel. And this is the waveform after parallel SG1 and SG2. We can see that they have a same value of ILG1 and ILG2. So we can see the difference of a parallel circuit and a series circuit. That's all from me. Thank you.
Okay, Bismillahirrahmanirrahim. Assalamualaikum. My name is Muhammad Afiq bin Sharifuddin. I'm from RK23. Okay, my part is part 2, 5.2 question 4. By showing the current and voltage waveform of both synchronous generator and load after paralleling condition for the time of 4.5 to 5 seconds, measure and analyze their real power. Okay, this is for A, current and voltage waveform for both synchronous generator and load. Okay, and then this table value RMS for B, current and voltage waveform of both synchronous generator and load values. And then this waveform for C, voltage line waveform for both generator. Okay, and then figure 5.8, current and voltage waveform of both synchronous generator and load after paralleling condition for the time of 5.5 to 5 second. And the last, the output power of a generator is not affected by the actual generator control because it closely match the input power from the prime mover, which also determines the speed of rotation of the generator, which the frequency of the open circuit induced voltage being directly determined by rotation speed. That's all for me, and thank you. Assalamualaikum.